So today, we want to talk about today, and you guys of course are not talking, you're listening, right? So rational functions, those are fractions, and they're discontinuities, okay? So what happens is this. It really does come down to what Cookie Monster said. Cookie Monster said, basically, don't divide by 0. Don't divide by 0. It doesn't make any sense. Even if you have 5 cookies, and you want to divide 5 cookies into 0 friends, it doesn't make any sense, right? So you cannot divide by 0. So today's lesson is finding where it divides by 0 and find out what happens. So I want to take a look at another graph. And in this case, let's rewrite this so it's easier to put in the calculator. This is really going to be an x squared minus a 1x minus a 2. If I FOIL it, right, I just FOIL it in my head because I'm kind of smart. X squared plus a 1x minus 6. Okay, again, and it's just easier to put it in because then you have to worry about double parentheses, okay? So I'm going to put this in my calculator, and I want to take a look at what it looks like, okay? So I'm going to go clear, go to y equals, clear that out. So I'm going to go parentheses. You have to use the parentheses because you need the entire top divided by the entire bottom. So I'll go parentheses, and I'll go x squared minus x, subtract 2 divided by parentheses, x squared plus x, subtract 6, okay? And I'm just going to put that in, and you don't need to necessarily put it. I just want you to watch, okay? Even if you want to put it in, great, but if not, just watch, okay? So then if I graph this, let's see what happens, okay? Okay, first of all, the graph goes totally crazy right here, okay? Graph goes totally crazy right here, okay? And that's at the value of -3. Value of -3. So -3 actually makes sense to me. Because at -3, right, x cannot equal -3, right? X cannot equal -3 because if x is equal to -3, we divide by 0, right? So that's a bad thing. It makes Cookie Monster so sad that he freaks out on us, okay? Cookie Monster freaks out by going off to infinity, and then or he goes off to -infinity, okay? So what happens is as you get closer and closer to -3, the value of the function goes off to infinity, okay? So it's not defined, okay? Now, the other discontinuity is that where x is equal to 2. X cannot equal to 2, right? Because if you x equals 2, it doesn't work. But I see the graph at 2. It looks like there's a value of 2, doesn't it? It does. It looks like there's a value of 2. But there's a hole there. Now, remember, in math, geometry, we talked about how wide is a point. Points technically don't have any space. So the hole is really, you ready? The hole is this wide. Because I could put 1.999999 in. That would work. You with me? I mean, I could put 1.999999 in. Or I could put 2.0001 in, right? So the value at 2 is the problem, right? How thick is that hole? This thick. So check it out. If I go to trace, and I try 2, enter. What's my y value? There is no y value. So what we know is this. Cookie Monster said don't divide by 0, right? So two things happened. We ended up getting an asymptote at -3, and we got a hole at 2. So let's write that down. We wound up getting an asymptote at -3. So I'm going to actually draw in a vertical asymptote at -3. So I'm going to go. So a vertical asymptote is just it's a borderline. It's a line to infinity, okay? And I get a hole at 2. Now the hole occurs because the problem is removable. If I go back to my original, I can cancel it out, can't I? So if the problem is removable, it's a hole. Let me say that again. If the problem is removable, then the value, the x value, is a hole. So we can't divide by 2, so it cannot equal 2, but I can get rid of it, right? So if I can get rid of it, if I can get rid of the problem, it's a hole. If I can't get rid of it, like the 3, I can't cancel, right? I cannot cancel, right? Agree? So I can't get rid of the x plus 3. So at -3, you can't get rid of it. It's non-removable. It's an asymptote. So if it's non-removable, it's an asymptote. If it's removable, it's a hole. So right at 2, we get this hole, okay? So how does the graph behave? Something like this, right? We just put it down. Let me put it in a different color. So the graph behaves a little bit like this. and a little bit like this. There's the graph. But the hole has to be there. You have to show the hole. And the calculator will not show the hole, because the calculator is going to do it correctly. The hole is really only that wide, right? We want to put the hole so we can see it there, okay? All right, let's keep going. Okay, does that make sense? If it's removable, if you can cancel out the problem, it's a hole. If you cannot cancel out the problem, it's an asymptote. The problem is always this: don't divide by 0. Don't make Cookie Monster sad, okay? All right, let me keep moving on, okay? So now, next one, graph y equals 1 over x. Let's check that out, okay? Enter, clear. 1 divided by x. Let's see what that looks like. Looks like that, okay? So it looks something like this. We're going to have here and here, okay? That's what it looks like. And it does have asymptotes, okay? This one has asymptotes. It has a vertical asymptote, and it also has a horizontal asymptote. Okay, the asymptote is where it goes off to infinity. Well, the vertical asymptote is right here. See how it takes off to infinity? I mean, it's a line of infinity. It's not part of the graph. It's just a borderline to infinity. So the graph goes off to infinity, goes off to infinity like this, and it goes off to infinity like that. That's an asymptote. They are special lines, border lines to infinity. And I have a horizontal asymptote right here. Because as x goes to infinity, it goes that direction. As x goes to infinity, it goes along that line, right? It will never touch this line, and it will never touch this line unless it gets to infinity. When it gets to infinity, it'll touch. But it can't get there, right? Okay. Make it a little bit of sense? Okay. Now, how about this one? Okay. First of all, before I even graph it, I got a pretty good idea what it's going to look like. Okay. What can x not equal? X cannot equal what? Everybody agree negative 2? Negative 2? Because if x is negative 2, you divide by 0. I can't cancel it out, right? I can't. So it has to be a vertical asymptote. So I know for sure, before I use my calculator, I know for sure I'm going to have a line that looks like that, right? Well, let's put it on my calculator. Let's take a look, okay? So I'm going to go 1 divided by parentheses x plus 2, okay? And if I graph that, let's see what I get. Sure enough, there's my asymptote, right? Exactly where I thought it was, right? My asymptote is exactly where I thought it was, so I'm going to go ahead and graph that in. Looks like this. Looks like this. So what I have is a vertical asymptote at x equals negative 2, right? I have a vertical asymptote at x equals negative 2, and I have a horizontal, slide over here, I have a horizontal asymptote at y equals 0. Because it really is heading off to, it has a horizontal asymptote as well. You see the horizontal asymptote? And it's heading off to y equals 0, height is 0, y equals 0, okay? So I've got a vertical asymptote at negative 2, can't divide by 0, and I've got a horizontal asymptote at 0, okay? So it's not that bad as long as you use your calculator. You guys agree? Okay, all right. Number 4. Before I even start, I know, Mason, I have a vertical asymptote. Where's my vertical asymptote? Okay, at 3. Okay, you guys agree? At x equals 3. It has to be at 3. So I put in my vertical asymptote, right? Now remember, these are not part of the graph. It's just boundary lines. Does that make sense? They're just boundary lines. So let's graph it and see what we get. So if I go ahead, clear, y equals, I'm going to go ahead and put my 1 divided by parentheses, x subtract 3, and then plus 2. I get a graph that looks like this. Okay, so now it's a little bit higher. So what happens is it's got kind of a center point at negative 3, 2. Okay, so we have our horizontal asymptote at 2. because this original graph just got shifted up to here. This original, its parent function, really got shifted up here because of the plus 2, okay? And so then the rest of the graph we just have to sketch in, right? This, and looks something like this, okay? All right, now, real quick, we've got the vertical asymptote, and we also now have a horizontal asymptote, which is at y equals 2. Okay, right across 2, that's my horizontal asymptote, okay? Lines of infinity, they're border lines to infinity, okay? Thumbs up, okay, thumbs up. It's not too bad as long as you can graph it. You just need to know two things, right? Where are you going to divide by 0? And 2, if you can use the calculator and graph it, you're going to be able to get it, okay? Now, return the page, right? Now, before I do anything on this one, it says identify the zeros, asymptotes, and holes. So before I do anything, I'm going to factor. Let's factor first, okay? So if I factor, I'm going to have a x minus 3 and an x plus 1, right? Over an x minus 2. Okay, you guys agree with that? Factor first. Can't get rid of my problem. So I know that x cannot equal 2. Everybody agree with that? So I know for sure that I'm going to have an asymptote of 2. And yeah, my calculator will show me that, but I can do that without my calculator. I'm smarter than my calculator. Can't divide by 0, right? Can't divide by 0, right? 2 would be a problem, right? Can't get rid of it. So I will have an asymptote of 2. Now again, if this doesn't make a whole lot of sense, we're going to graph it anyway, okay? But right at the bat, I know for sure I'm going to have a vertical asymptote there, okay? Now, what I want to do next is, let's take a look at it in my calculator, okay? So if I go y equals, clear, I'll go parentheses, x squared minus 2x, subtract 3, divided by parentheses, x, subtract 2, and let's see what I get. Graph. Alright, so it looks something like that, alright? Seems to go through at this point right here. This point right here is going to be 1.5. I'm going to show you why in a second. It goes through at 1.5. Goes through at 3/2. And it also goes through at -1. I'm going to show you why in a second, okay? I'm going to prove to you, okay? So it goes like this. Okay. It's going to for sure go through at 3, and I'm going to show you why. It goes like that. Okay. All right, asymptotes. I know I have an asymptote at x equals 2. That's my asymptote. My zeros. Okay, we're going to be smart. Zeros. Okay, listen carefully. 0 on the top is okay. 0 on the bottom is bad. 0 on the top is okay. 0 on the top is 0. 0 divided by 5. 0. 0 divided by 10. 0. 0 on the top is okay. So the two values that make 0 on the top are 3 and -1. Do you agree with that? If 3 would make it 0, -1 would make it 0. Well, check it out. 3 is a 0, right? And -1 is a 0. So to get the zeros, we just we find values, x values on top, called the numerator, by the way, to make the function 0. Okay, in this case, it's going to be x equals 3 and x equals -1. Okay, and there they are, 3 and -1. The calculator showed me that anyway, didn't it? But it makes sense to me, okay? My y-intercept here is like any y-intercept. How do you find the y-intercept? Let x equal 0. So the y-intercept, I'll write that up here, the y-intercept, let x equal 0, okay? So to get the y-intercept, let x equal 0. So if I go back up to the original, and the x is 0, then kind of squish that. What do you see? If x is 0, what do you see? 3 over 2, right? X is 0, I get 3 over 2, which is 1.5. Remember I told you I knew it was 1.5, and that's why it's called 1.5. Kind of makes sense, doesn't it? Okay? Holes, there are no holes. Nothing, the problem is not removed. So there's no holes in this problem. Okay? No holes. Okay? Alright, let's slide up and look at this one. There's no holes. Okay, there we go. No holes. No holes. Slide. Now, let's graph this one. But before I graph it, I'm going to factor it. I'm going to go x plus 2, x plus 3 over x plus 2, x minus 2. Okay? Now, before I graph it, I'm going to tell you something I know. Okay? This is really important. Okay? I'm going to tell you what I know. Right off the bat, I know this. There is a hole at x equals negative 2. I know that. And I know there's a vertical asymptote at x equals 2. Okay, before I do anything, before I even graph it, I'm going to tell you, I know this for sure, okay? Because right off the bat, I know that x cannot equal, negative 2, and x cannot equal 2, okay? So, I'm going to go back to what Leora did on this problem right here, okay? What Leora did on this problem, she said, well, I can just cancel, right? So if you can remove the problem, it's a hole. I can remove the problem of negative 2, can't I? See, I can cancel it out. If I can remove the problem at negative 2, it's a hole. If I can't remove it, can't cancel that out, right? If I can't remove it at 2, it's a vertical asymptote. Let's graph it and see. And I'll show you how smart I am, huh? Anyway, yeah, Mr. Davies, Mr. Arrogant, huh? So let's go ahead and graph it. Y equals, let's clear that out. We'll go parentheses x squared plus 5x. We're finally doing math I like. It's good stuff. This is fun math. Leora, you liking this stuff? Mm-hmm. All right. Graph. This is cool stuff, isn't it? No? Okay, what did I tell you? I told you there would be a vertical asymptote. Check it out. I told you there'd be a vertical asymptote of 2. Well, you know, there it is. Right? Now what about the hole? Negative 2, so let's do a trace, because at negative 2, it sure looks like at negative 2 there's a value here, doesn't it? Okay, but if I try my trace button, I go to trace, I go negative 2, boom. What's the corresponding y value? There is none, right? There's no y value, because it's a hole, right? So at this point, all I got to do is just draw in my graph, right? My graph is going to look something like this. Put my vertical asymptote in at 2. Right? And I'm going to go ahead and my zeros I'm going to have at negative 2, right? But it can't be negative 2, so at negative 3. And it's going to look something like this, okay? It doesn't have to be perfect, not yet. It'll have to be perfect later on. What's that, negative 1.5? Goes through there. And it's going to come down like this. Okay. All right. So my zeros. All right. X equals negative 2 and x equals negative 3, right? Except we said x cannot equal negative 2, so it's going to be just, your zeros are just at negative 3. Can't be negative 2. The zeros come from the top. The 0 on the top is 0. Negative 2. Negative 3. We already said it couldn't be negative 2, so just negative 3. Okay, holes. We have a hole at x equals negative 2, right? Asymptotes, vertical asymptotes is at 2. Okay. Crazy, huh? This is crazy stuff. Fractions. It all comes down to Cookie Monster. If you're going to blame anybody, blame Cookie Monster, because he was right when he said, don't divide by 0. It's going to make him sad.